All right, we got three vertices of a trapezium, another word for a trapezoid. A trapezoid is a quadrilateral that has one pair of parallel sides. Okay, so let's do a quick sketch with the points they gave us. We've got 3, 5, we've got negative 5, 4, and we've got 1, negative 5. All right, now, a trapezoid. We know that BC and AD are parallel. We're trying to find point D. We know that this angle at D is going to be a 90-degree angle, so I can do kind of a rough sketch. I'm not actually going to be able to find D by doing this, but I can tell you the general area where it could be. So anyway, I know the two sides are parallel, and basically my strategy is I'm going to find the slope of BC, and then find the slope of CD, and then I'm going to write equations for both CD and AD, and then I'm going to solve simultaneously. And that's going to give me this point where the two lines intersect. So first, we've got y2 minus y1 and over x2 minus x1 to find the slope. I've got BC. I got both these points. I can find the slope. That's going to be negative 3 halves. So now that I know BC, I also know AD. Since they're parallel, they must have the same slope. And since I know AD, I know that CD is going to be the opposite reciprocal. It's going to be 2/3. So now, in order to find the equation of a line, I'm going to use the point and the slope, where I've got point C, 1, negative 5, and I'm going to plug it into the formula y equals mx plus b, because I know eventually I'm going to have to solve them simultaneously. So why don't you do that? Plug it into y equals mx plus b and find out what b is, and then start back up again. All right, so here's what I got. Negative 5 is equal to 2/3 times 1 plus b. I'm going to change this negative 5 to as a fraction of 3, so that's going to be negative 15 over 3, same thing as negative 5. But see, now I can subtract the 2/3 on both sides, and I find out it's negative 17/3. So that equation is going to give me y equals 2/3 x minus 17/3. I'm going to do the same thing for the other equation. I've got AD slope, and I have the point A. So what I want you to do is plug that into y equals mx plus b, find the b, and then write the equation of the line, and then start back up again. Awesome. Okay, so 5 is equal to negative 3 halves times 3 plus b. I look at the 5, I'm going to multiply this and get negative 9 halves. 5 is the same thing as 10 halves, so now when I add 9 halves to both sides, I get 19 over 2. And then I write the equation. It's going to be negative 3 halves x minus 19 over 2. I'm sorry, plus 19 over 2. So now what we've got to do is make these two lines equal to each other, solve simultaneously, and find the point where they intersect. So pause it and try that and start back up again when you're ready. Okay, solve simultaneously. I've got this equation and that equation. I'm going to make the two rules equal to each other, since the y's must equal each other at the point of intersection. And you notice I got these fractions. I want to get rid of them. So the least common multiple is going to be 6. If I multiply everything times 6, these fractions are all going to get rid of their denominators. This is going to turn into 4x. I've got this is going to be 34. This is going to be 9x, and then 57. So now I've got an equation without fractions that I can solve, and I find out that x is going to be 7. And then when I substitute that back into the original, I'm going to find out that y is going to equal a negative 1. So that's the point where the two lines intersect. That's going to be point D. And let's see how we did. If I go back to my graph, go 1, 2, 3, 4, 5, 6, 7, negative 1. Well, obviously my sketch was a little bit off, but it's in the ballpark. I knew where it needed to be. Okay, so hope that helps. Thanks for watching.